Hello dear children, let's begin with our new video on a new lesson. This time we're going to learn about the lesson that is separation of substances. So let's take a look at our lesson objectives. In this lesson we will learn about what separation is and why it is needed. Then we will learn about what a mixture is. We'll learn about the types of mixtures, the properties of mixtures, and the separation of components from mixtures, how it can be achieved. Let's take a look at separation of substances. What is separation? You must have noticed how we use a filter or a sieve to actually separate the tea leaves when we prepare tea, right? If you're given a plate of poha in which there is a big piece of green chili, you would like to remove the green chili before you eat it. Or maybe the curry leaves is what you do not like to consume, so you'll have to put it aside before you eat the plate of poha. So we use separation for such simple things in our day-to-day life. But separation plays a much important role in different industries, for different applications in our day-to-day life. Let's take a look. A few more examples. So you must have seen that your mother or your grandparent is sitting and separating stones from a grain or a pulse before preparing it. So grains and pulses, they come from the fields, and very often they might have large substances such as stones or perhaps small insects or small pieces of dirt in them, and very often they sit down and they separate it using their hands by simply picking it and removing it. So this is also an example of separation. Again, you must have noticed that when we get milk in the morning, what we do is we boil it in a pot and then we cool it down completely and we separate a layer of fat that is formed at the top, that's separated to the top, is skimmed off, and it is used, it is stored, and then later on it's used to prepare maybe clarified butter or other things. So here also separation plays an important role, because if we were not able to separate the components of milk, we would not be having so many different milk products such as ghee or butter or cream. Then you have almost also have seen the way in which milk is or curd is churned or it's turned to remove the butter. The butter or the fat separates when the milk or curd is churned, and then it can be used to prepare butter and buttermilk. Another example of separating a liquid from a liquid is when you have something like a pickle or a gravy or a curry in a restaurant. You must have seen the layer of oil that floats on the top, and then we do not want to consume so much of oil because it's not good for our health. So we try to separate that layer of oil by maybe skimming off that oil using a spoon, or we just try to take the curry that is there underneath without actually serving the oily part of it, right? So here also separation is important. So what is the need for separation? From these different instances that we have seen, we could see that in certain cases we need the different things that we have separated. Maybe there are two things that we have separated and we require both of them. In some cases, it's just that we do not desire one of those things and we want to remove it from the whole thing, and so separation is required. So let's take a look. So why do we separate substances? The first instance, the separation process is to separate stones from rice. So why do we? What is the purpose for which we do the separation? Yes, we do the separation to remove the impurities or harmful components, because definitely you don't want stones in your rice. It is harmful for us. It is an impurity and you want to separate it. Then what do we do with the separated component? What would we do with the stone that we have just separated from the rice? Yes, take a look. Yeah. we would throw away the impurities. So the answers would match like this: 1, C, 2. Let's go to the second separation process, that is churning milk to obtain butter. Here, what is the purpose for which we do the separation? Yes, we separate milk from butter to separate two different but useful components. Because when you separate milk from butter from milk, you get butter and buttermilk, and both are quite useful to us. Both are very nutritious and very good for us. So what do we do with the separated components then? We use both the components, 2A3. So then the last one is to separate T from these. Why do we do this? We do this because one of those components are only useful to us, the other has already done its job, and we do not need it in that particular thing again. So we have to separate it so that we can throw away the solid component. So now that we have taken a look at the need for separation, let's summarize what we have understood. The reason for separation of substances: to separate two different but useful components from a mixture. That is, both the components are useful. Then we can also do separation so that uh, one of the components are not useful for us, or one of the components has already done its job and then needs to be separated. For example, another example is when we prepare, say, a pulao or a biryani. We put whole spices like cardamom or black pepper or cinnamon sticks, which appear large and bulky, right? So you do not want these pieces to come into your mouth. So what we do is we separate those whole spices before we actually eat the food that has been prepared. So here the spices have already done their job of flavoring the food as soon as it's put into the hot oil and the food is prepared along with the spices. So now it can be removed, but the taste and the flavor of the spice remains in the food. This is an example of separation of non-useful components from the mixture. We also do separation to remove impurities or harmful substances from the mixture. So we have been talking about mixtures a lot since the beginning of this video. So what exactly are mixtures? Let's take a closer look. We have learned that anything that has weight and occupies space comes under the term that is called as matter. So matter, as you've learned in your previous class, is made up of really small units, which we call as particles or atoms to be more specific. And we have learned that there are only certain types of atoms that exist in the universe, and almost everything that we see and that has weight and occupies space is made up of these different types of atoms in various combinations or in their pure form. So then matter, which is pure substance made up of only a single type of atom or maybe a combination of types of atoms, that is molecules, are what we call as pure substances. When we look at a copper teapot, the whole thing is made up of only copper atoms of copper which are joined together, and that is why we say that it is made up of an element, because it is a pure substance made up of only one type of atom. When we look at something like, say, baking soda, we can see that they are made up of molecules. The molecules are made up of certain combinations of atoms, and each molecule looks exactly the same, right? Each molecule is made up of the same atoms in the same combination, the same arrangement. So we say that it is a compound. It is a compound. Now let's take a look at mixtures. Then what are mixtures? See, when we look at mixtures, mixtures can be made up of different combinations of different atoms or molecules of different substances. For example, when we talk about tea, there are the particles that make up the tea leaves. Then there are the particles of fat from the milk. Milk itself is a mixture of so many different substances, including water. So all of these come together to form a mixture. Then what is the difference between, say, homogeneous mixture and a heterogeneous mixture? If you look at tea or, say, air or lemon juice, which has been mixed thoroughly, you can see that it is uniformly distributed. All the components or the parts of that mixture is uniformly distributed throughout the body of that mixture. And that is what we call as a homogeneous mixture. When a mixture is not, when the components of a mixture is not uniformly distributed and can easily separate out on standing, that is, you keep it still for some time and it separates out, then we call it as a heterogeneous mixture. For example, if you look at figs, the seed part of it is concentrated on certain part of the fig fruit, and the pulp part is concentrated on another part of the fig fruit. An example of a heterogeneous mixture. I hope you've understood about homogeneous and heterogeneous mixture. Now take a look at this. When we say the word mixture, this is the first thing that would come to my mind. Mixture is another name for, say, something called as farsan in Maharashtra. Farsan is made up of many components which are of different sizes and shapes. And it also has peanuts in it, it has curry leaves in it, it has poha in it. So it has so many different components. And depending on the person who's preparing the farsan and for whom is they're preparing it, they would add these different components in different proportions, right? That is, maybe if you like peanuts, you could add more peanuts, or if you like, say, a particular type of bale or the poha more in it, then you could add more or less of that. Then the mixture, you can decide what the proportion, that is, in what extent each component of the mixture is there in your mixture. So mixtures are formed when two or more substances, they are mixed together in any ratio. What does any ratio mean? It means that here in this mixture, when you separate it, you have the orange component, and then there's a green component, and then there's a red component, and then there's a yellow component. Now we can have more of the orange, less of the yellow, or less of the green, more of the red, or more of, say, yellow, green, red, and less of yellow. So you can have it in any different ratio or proportion, and it would still be a mixture. Depending on whether it's uniformly distributed, these components are uniformly distributed throughout the mixture, or whether they can easily separate out, these mixtures can be homogeneous or heterogeneous mixtures, as we have already seen. Okay, let's take another look at homogeneous and heterogeneous mixtures. The best example of homogeneous mixture is, say, air. So right from your younger classes, you have learned that air is a mixture of different types of gases, which includes oxygen and carbon dioxide, nitrogen, and other rare gases, and it also has water vapor in it. And then you have learned about certain numbers which indicate the proportion in which they are present. So any part of air you take, the maximum number of atoms would be made up of nitrogen. They would be nitrogen gas, which is maximum in it, because we have learned that 70% of it is made up of nitrogen. And then you would have lesser of oxygen and very little of carbon dioxide in it. Any part of air you take, any sample of air from any part of the world you take, you would find this ratio to be the same. That is why we call air as a homogeneous mixture. Then when we look at heterogeneous mixtures, as in ice and water, you can see that the ice would always float, it would separate from the water. Cereal and milk, you can see that the cereal is always floating or concentrated in one part, and you can actually skim off and have the milk on its own without taking in too much of the cereal if you wish to. If you mix oil and vinegar, again, it would separate to two different layers. So these are all good examples of heterogeneous mixtures, just to make it very clear. So homogeneous mixtures would have a uniform distribution of the particles which make it up. Heterogeneous mixtures would have non-uniform distribution of the particles which make it up. Let's take a look at the properties of mixtures then. This is very important. The components of a mixture can be present in any proportion, as we have seen earlier in the example of a mixture of say person. I said that you can mix any amount of each of the component and you can still get a mixture. The components of a mixture retain their original properties. What do you mean by this? Say you have a certain type of this you can relate this very easily to the properties of the different gases which make up air. If you're going to separate oxygen and carbon dioxide from air, the oxygen would still behave like oxygen. Hmm? Oxygen would help in the burning process. Oxygen gives life because animals take in air, and carbon dioxide would still behave like carbon dioxide. Carbon dioxide actually does not support the burning process, right? So it would help in putting out the fire. So whether it's in a mixture or whether it's separated and on its own, the components of a mixture would still retain their original properties. Another example, when we mix different substances like green chili or peanuts to prepare poha, the potato would still have its flavor and taste. The green chili would still be spicy. The peanuts would still be crunchy. Each component of the mixture will have their original properties. It will not change in a mixture. This is a very important feature of a mixture, property of a mixture. Mixtures do not have fixed boiling point and melting point. This means that if you take a mixture of, say, salt and water as compared to the same quantity of water, it would take lesser time to bring the water to a boil than the salt and water. This is because salt would actually uh, push the boiling point of water further because it is actually interfering with the boiling process. So then mixtures will not have a fixed boiling point. This and again, this will also depend upon the amount of the salt which has been added into the water. Let's take a look at the different types of mixtures that are possible depending on the phase of the components. The phase of the component can be solid, liquid, or gas. So we have different types of mixtures that are solid in solid, solid in liquid. And when a solid is put into a liquid, the solid can either be soluble in the liquid to form a solution or it can be insoluble. When a liquid is mixed in a liquid and the components of a mixture are liquids, the liquid can either mix completely to form miscible liquids or miscible mixtures, or they can separate into different layers to form immiscible mixtures. Gases can also mix in liquids, as we have already seen that there are gases which are mixed in water, which supports aquatic life. So gases can also be mixed in liquid, and gases can mix in gas, the best example of which is air. Now, how can we achieve separation of the components of a mixture? The substances to be separated may be particles of different sizes or materials. As we have seen, the components can be in different phases. They can be of different sizes. They can be in different quantities. And we can make use of all of these things to achieve the separation. So we've seen a very important property of mixtures, that the individual components of the mixtures retain their properties, and because of this we can use the difference between the property of that component which we want to separate as against the property of another component of the mixture to achieve the separation. So mixtures are made up of different components, two or more components. So that's it for this lesson. Let's quickly recap what we have learned. Separation is done to remove impurities or useful components from a mixture. Mixture can be made of two or more components combined in any ratio. Components of a mixture can be solid, liquid, or gaseous phase. Mixtures can be homogeneous or heterogeneous. Components can be separated from a mixture on the basis of the differences in their individual properties. So then children, I hope you have enjoyed the lesson and I hope you have understood about the separation of substances. The introductory part of this lesson has been completed. We will learn more about the separation methods in the next video. I'll see you again. Bye-bye.